Hi everyone, in today's lesson we're going to talk about how we can use integration to find area under the curve. So that will be our first goal, and then the second goal for us will be to determine the difference between area and integration calculations. So it says, use integration to calculate the area bounded by the curve and the x-axis of the following function over the given interval. So here's my function and here's my interval. So if we go based off of what we did the past couple of days, a lot of you are probably thinking the best way to do this would be to go from -3 to 3 of x squared dx. So take a minute, type that into the calculator, and then hit resume when you're ready for the answer. All right, so when you type that in, you should actually get 0. And this is actually not something that you want. How is the area under the curve going to be 0? That doesn't make any sense. So integration, using these definite integrals, don't always work because see how we got 0? Area under a curve could never be 0. So let me explain why this definite integral gives us 0. But first, we're going to cross this out because this doesn't make any sense. We're not going to use that. All right, so let's draw our picture of x to the third. So I'm going to try to be as accurate as possible. And 1, 2, 3, 1, 2, 3. So the area under the curve, I'm just going to highlight from 0 to 3 is right about here, all this stuff, right? From 0 to 3. I'm highlighting that there in yellow. And the area under the curve from -3 to 0 will be about here. And when you perform a definite integral from -3 to 3, it represents the area under the curve from this spot to this spot. But if you notice, this is below the x-axis and this is actually above the x-axis. So if you remember, we talked about that. When we're above the x-axis, this is really a positive answer for the integration. And this, when it's below the x-axis, is a negative integration. So what you're going to have to do, if I'm asking you to use integration to find the area, you're going to have to split it up into two pieces. So you have the integral from -3 to 0 of x to the third dx, and that's this green spot. So the integral from -3 to 0 dx. So type that into the calculator first before we do anything, and hit resume when you're ready for the answer. All right, so when you type that in, you should have gotten -20.25. So basically the negative, all that it represents is that it's under the curve. So you have to take the absolute value if you want the area. So this absolute value will be positive 20.25. Then we're going to separately take the area from 0 to 3, which is here above the x-axis. So we have from 0 to 3 of x to the third dx. So take a couple seconds, plug that into the calculator, and hit resume when you're ready for the answer. Okay, so I got 20.25. And again, that area is positive because this area is above the x-axis. So therefore, this if I want to find the area for all of it from here to here, from -3 to 3, I have to add these two together. So it's going to be 20.25 plus 20.25, which gives us 40.5. Again, you can say units squared if that makes it easier for you because we're talking area. So just to recap, from -3 to 3, if I type this in just the way I see it, it's going to take this negative area and add it to this positive. So that's how it got 0 because it did -20.25 plus positive 20.25. So when you're calculating a definite integral, it accounts for negatives and positives. But if I'm asking you to use integration to find area under the curve rather than doing Riemann sums, you have to graph it out and see where it crosses the x-axis and then add them separately. Okay, let's try another example. Okay, so this example says use integration to calculate the area bounded by the curve and the x-axis of this following function over this interval. So take a minute, pause the video, and graph your picture. And then hit resume when you're ready. All right, so my picture isn't perfect, but the idea is that it's a sketch. And a lot of things are happening here. I want the area from -6 to 3. So I'm going to highlight all of that. So here's -6, but I only want to go from -6 to -5 because that's where it's positive. And then I'm going to use green again for the below the x-axis. So from here to here is all below my x-axis, so that'll have a negative area. And then I want to go from, this is x is 1, so 2 and 3. So the area above the curve will be all of this, so I can go ahead and kind of highlight all of that. So if you're going to notice, these two integrations will be positive, and then this integration would be negative. So when you drew your picture, it was really important that you figured out where it crossed the x-axis, right? The roots have you. Those are going to be the points where you're going to separate the integrals. Now, it may not always work that it hits exactly at a specific spot on the x-axis. So we need to figure out a way to find those values without using the calculator. So what we would do is basically we're asking, where does y equal 0, or where are the roots? So we're going to set the equation equal to 0 and factor and solve. So this is just add multiply, right? So this would have given you x minus 1 and x plus 5. And this root would be at, positive 1. And the other root would be at -5. And that's exactly what happened, right? We have our root over here at -5 and our root here at 1. So sometimes this step would be necessary if the calculator didn't clearly show you those two endpoints. So we have 3 integrals this time that we're going to add up. So we'll start from the left. We'll do -6 to -5. That would represent here, this is x equals -6 to x equals -5 of x squared plus 4x minus 5 dx. And then we're going to add that to the integral from this here is at -5 all the way to positive 1. So we would write that as the integral from -5 to 1 of x squared plus 4x minus 5 dx. And then the last one is from 1 to 3. So we're going to integrate from 1 to 3 of x squared plus 4x minus 5 dx. Now just keep in mind that since this one is under the x-axis, we're going to have to take the absolute value. So if it helps, put absolute value bars around that so you remember to take the absolute value. All right, try these on your own and hit resume when you're ready for the answer. All right, so these are the numbers that I got. So for the first one, I got 3.3 repeated, so approximately 3.333. The second one, I got -36. So if I take the square absolute value of that, I get 36. And the last one, I got 14.666, 6 repeated. So we're adding this 14.6 with this 36 and this 3.3 repeated. And when you do that, you add them up and you get 53.9 repeated, so I'm just going to round that and say approximately 54. Okay, cool. Let's try one more example. All right, so this one says use integration, same thing, to calculate the area under the curve from this interval of -2 to 5. So before we graph it, I want to just show you the algebraic steps again. So we're going to find the roots algebraically. So set y equal to 0. So y equals 2x squared plus 5x minus 3. Let's factor this one. You can use AC method where you multiply those two together, or you can do guess and test. I'm going to do guess and test. So 2x and x, 3 and 1. I believe that should be a positive and a negative. So this should be x equals 1/2, and this should be x equals -3. All right, so here's my quick little sketch. And before I sketch it, I'm noticing a little bit of a typo. I want to go here from -5 to +2 instead. So just correct that on your papers, please. So here's my sketch from -1, 2, 3, 4, 5 to +1, 2. So I'm just going to graph a couple of key features. I noticed that it crosses the x-axis, the y-axis at 3, and it crosses at 1/2, and it also crosses at -3. So to the best of my ability, I'm just going to draw a little bit of a sketch. So it should look something like that. Again, not perfect. Yours should be a little bit better, but that's the idea. And let's calculate the area under the curve from -5 to 2. So here's -5. So -5 to -3 is above the x-axis. +1/2 to +2 is all above the x-axis. And from -3 to +1/2 is all below the x-axis. So to calculate the area under the curve, from the curve to the x-axis, we're going to break it up into 3 pieces. Those 3 pieces will be from -5 to -3, -3 to +1/2, and 1/2 to +2. So if you want, take a minute, try it out, and hit resume when you're ready for the answer. All right, this is what I got. All right, so just a couple things. This middle area is underneath the curve, so you need to take the absolute value. So for the first one, I got 19.3 repeated, and then I'm adding it to a positive after I take the absolute value, 14.29-ish. And then the last one I got 10.125. And when I added these up in the calculator, I used every single decimal value to get this approximate answer of 43.75. So when you practice problems, I will specifically tell you what to round each one of these to so that you get the correct answer for your total area. Okay, that's it for today. If you have any questions, please let me know. Have a good one.